In this video, we're going to talk about normal or Gaussian distributions in Power BI, mostly Power Query. If you've seen some of my previous videos, you know that I like to generate data inside of Power Query for demos or doing some modeling. And I was working on a different thing recently that I'll make a video about in a bit, where I needed some normal distributions for some date times. So I started looking into how about going to do that. Certainly it is possible with DAX. If you just need a simple Gaussian distribution, you can use the norm INV function, and that works well. So in this case, I've generated a 10,000 row data set, and in every row grabbed a number from that distribution with the average of 100 and a standard deviation of 12. And this works well, and you could take this a little further. But in my case, I needed to do a whole bunch of Gaussian distributions, and just in general, it's better practice to do stuff in Power Query, and you can do more on that side. So I started to look into how about to do that. There isn't a norm INV function on the Power Query side. Fortunately, I found this blog by Sandeep, who came up with a clever way to and provided a function to generate a number from a distribution, provided the mean and standard deviation. So I took this function and adapted it for what I needed. So if I jump over to the query editor, I've got a bunch of functions to just walk through quickly here, and I'll put a link in the description so you can grab this M code as well if it's helpful to you. But if I just look at this first one, it's pretty much the same code that he had on his website there. Note that it uses two different number.random functions, and that is important for it to work. So what I needed was, instead of getting a single number, which this function does, you just give it a mean or standard deviation and it gives you back a single number from that distribution. I needed a whole list of numbers from the same distribution. So I modified the function to provide a count as well, and then I'd simply just made a list of numbers 1 to the number of count that I put in, and then basically use his function again, and then just use list.transform to transform each of those numbers into a random number from that Gaussian distribution. And that worked well. I'll show you one of the outputs in a second. And I have a previous video talking about random numbers, and you can use the seed parameter of list.random, for example, to get the same random number every time, which is good, again, when you're doing demos or helping people so that they all get the same number or output as you do. So I made a version of this that takes seeds in there. And as I mentioned, this requires two different random numbers, so I actually needed two different random lists, each with a different seed, so that I could meet that requirement. And again, I won't go through the M code, but basically had the same starter list. In this case, I needed this really just to index the values from the other one, so I needed to start from 0 instead of 1, so I went to count -1. And then I just buffered the two different random lists, each with their own seed value, and then went ahead and did the list.transform, grabbing a number from each of the lists. The underscore is just the current value, iterating through the list. So I'm grabbing in the first iteration the 0 item, the first item from the first buffered list and the second buffered list, and it worked very well. I won't go through it here, but for the application I needed date times centered around a certain time of day with a given standard distribution to have some concentrated activity there at a certain time of day. And so I further adapted it so that I could input a date time and then get a list of date times out. So I used these functions above, and I'll just share a couple of other points there, but basically each of these starts with, this is the second one I showed here, just the normal random normal list without a seed. This is the same function, just with some different values so that I can compare it head to head. This one I'm doing 10,000 values with a mean of 300 and a standard deviation of 30. And then I did the same thing with a list that had two different seeds, and the seeds are just any integer value will work there. So if I close the query editor, just mention a couple other things. One is, if you want to visualize a normal distribution, you can do that pretty easily with the native visuals. In this case, I had to add a bin column. You can use the groups function, groups columns feature. I did it in Power Query, where I just added a column and rounded it, and then a simple count measure, and I can see that I got the desired distribution there. This one was a mean of 100 with a standard deviation of 12, I think. And then you can also use the deneb visual to view it as well. In this case, I didn't need the extra bin column, and I can do the counting right in the visual as well. And just to show you, it's a real not much code at all, and I can just add the bin in the encoding. In this case, I wanted the bin size to be a value of 1. I could have put other values there, and then my Y is just a count aggregation, and so I get the same chart basically. If you do need to fit normal distributions, actually the deneb visual has a number of good options for regression. You can do linear fitting, log, quad, exponential, which I thought might work for this, but did not. There's a few other options too. So it didn't work for the normal distribution, but of course you can do that pretty easily with R or Python. They're both good for that. In this case, I did it with Python, found some code online with the SciPy stats package there. Was pretty easy to both display and then fit that, and you can see that the average of 100 and the standard deviation of 12, this got very close as well, so that was good confirmation there as well. And then the last thing was just what I was talking about with the seed. If we, for example, look at this one that is not using the seed value, and I refresh the data, you'll notice one, of these are pretty fast, but two, that the number changes here. So it's getting just a different, it's random, getting different distribution that meets the criteria. But if I use the one that had seeds and refresh it, you'll see that I get the exact same mean here, pretty close to what I put in, but it stays constant there, and that's actually what I needed for this other application, was to have a consistent random distribution. So there's just a few tips there. Again, I'll post the link in the description so that you can grab that M code if you need it for any of your applications.